Lesson 10.8, Problem Solving, Changing Dimensions. Essential question. How can you use the strategy to find a pattern to show how changing dimensions affects area? Unlock the problem. Jason has created a 3-inch by 4-inch rectangular design to be made into mouse pads. To manufacture the pads, the dimensions will be multiplied by 2 or 3. How will the area of the dimensions be affected? Use the graphic organizer to help you solve the problem. Read the problem. What do I need to find? I need to find the area of the design. So add a page. I need to find how the area of the design this is the portion that you will fill in. The area of the design will be affected by changing the dimensions. The portion that I've underlined is the portion that you will fill in your graphic organizer on page 577. Page that looks just like this. So what I have written down on that second page, you will write in here. I need to find how the area of the design will be affected by changing the dimensions. Okay, what information do I need to use? I need to use the dimensions, so the dimensions. Obviously you're going to write a little bit smaller, it's just very hard with my new stylus, it's a bit large, of the original design and okay, so what information do I need to use? I'm looking at this portion here. I need to use the dimensions of the original design and the numbers by which the dimensions will be multiplied. So you are going to write in the portions that are highlighted into the fill in the blank on your page. So what info do I need to use? I need to use the dimensions of the original design and the numbers by which the dimensions will be multiplied. Okay, moving on. How will I use the information? Now, I'm looking at this portion of your text. I can draw a sketch of each rectangle and calculate the area of each. then I can look for patterns in my results. Solve the problem. Sketch. 6-inch by 8-inch rectangle. Dimensions. 6-inch by 8-inch. So this part here is telling you the dimensions of this sketch. This is the original rectangle that we are going to use. Now, the multiplier here on the top is 1. The multiplier on the bottom is 2. A equals 6 times 8 equals 48. Now, I want to point out quickly in this first section right here, the dimensions that they started off with was 3-inch by 4-inch. So, the multiplier 1, they used the same numbers. On the second portion, they used the multiplier 2. So they took 3 times 2 is 6, which is how they got that number. And then they took 4 times 2 is 8, which is how they got that number. That will be important for when we use the next multiplier down here, which is 3. They're using these dimensions here that are the original dimensions of the original rectangle. So, if our multiplier here is 3, we are going to do 3 times 3 is 9, and 4 times 3 is 12. So the dimensions here we need to fill in are 9 inches by 12 inches. And then area, so A equals 9 times 12 is blank. If you use a calculator, this is a portion that you could use your calculator on. So you're going to plug in 9 times 12 equals 108. And then you would use the same label, which would be inches, and then don't forget to put squared because we're talking about area. So let's erase this. So when the dimensions are multiplied by 2, the area is multiplied by 4, which is 2 times 2. When the dimensions are multiplied by 3, the area is multiplied by 9, which 9 is 3 times 3. Now I'm on page 578. Try another problem. A stained glass designer is reducing the dimensions of an earlier design. The dimensions of the triangle shown will be multiplied by 1/2 or 1/4. How will the area of the design be affected? Use the graphic organizer to help you solve the problem. Read the problem. What do I need to find? So I'm looking at this section here. What do I need to find? How the area of the design will be affected by reducing its dimensions. So you need to write the highlighted portion here. What do I need to find? Moving on. Read the problem. What information do I need to use? Right here. What information do I need to use? The dimensions of the dimensions of the original triangle and the multipliers by which the dimension will be reduced. This is what you are going to write in under what information do I need to use in that second box. Okay, now we are on to solve the problem on the bottom portion of the page. Sketch. Multiplier 1. Area 1/2 times 16 times 6 equals 48. Okay, if you look up at the problem that it gave you, it also gave you a picture of a triangle, and we know that the area of a triangle is 1/2 times base times height. That is where this 16 comes from. 16 is the base, and then 6 centimeters is the height. So 1/2 times 16 times 6 equals 48. If you go ahead and multiply those numbers together. If you move on to the second portion, our multiplier changes to 1/2. So we are going to do A, which is area, equals 1/2 times 8 times 3. And then that equals 12 centimeters squared. Now, some of you are probably thinking, where did those numbers come from? So, the multiplier here is 1. So these numbers up here were multiplied by 1, so that means that they stayed the same here. Our multiplier now changes to 1/2. So these numbers that were in our original picture, 16 and 6, each of those numbers get multiplied by 1/2, which is the same thing as being divided by 2. So if we take 16 divided by 2, we get 8. And then if we take 6 divided by 2, we get 3. That is where those numbers come from. Okay? So let's go ahead and move on to the second portion of this. Our multiplier was 1 to begin with, and then it was 1/2. Now our multiplier is going to be 1/4. Still in height. This portion says sketch. We did not have to sketch for the original one here because it was already given to us up here. But we do have to make a sketch for the second example. So let's draw a triangle and put it together. We're going to draw a line down it to represent the height, and then a little square to make a right triangle, or to make a 90-degree angle to show the height of the triangle. This is going to be 4 centimeters, and the height is going to be 1.5. So if you look at this picture, we had 8 centimeters for the base, 3 centimeters for the height. So we did 8 divided by a half, because half of a half is 1/4. So we got 4 centimeters, and then 3 divided by 2 is 1.5. That is where those numbers came from. So area equals 1/2 times 4 times 1.5 equals 3 centimeters squared. And then again, 4 centimeters is the base. That's why I plugged it in here. 1.5 centimeters is the height. That is why I plugged it in here. That's where the numbers are coming from. Okay. So when the dimensions are multiplied by half, the area is multiplied by 1/4. When the dimensions are multiplied by 1/4, the area is multiplied by 1/16.